Greetings and salutations. This is Hugh Arts, the biggest YouTuber ever. Yes, a couple of words I suspect tonight this one's going to hurt. But I'm in extreme company tonight. I put my thinking cap on. My guest tonight is someone who truly knows what he's talking about, unlike our subject of our video tonight. As a PhD, he's an expert in his field, having learned pretty much everything available about his subjects. But he's not just a PhD, he's gone further. He's also a professor of physics, teaching generations of future scientists, mathematicians, and engineers who will use what they learn from him to keep our society functioning for decades to come. Again, unlike our subject. But he's gone even further than that. He helps the Indian Space Agency figure out how to put probes on the moon. Everyone, please give a big, huge-ass welcome to Professor Phil Bell. Happy New Year.
Thank you very, very much.
Good.
It's good to be here, and let's have some fun with that debate that young
afternoon
with young Leo.
Yes, but it's New Year's Eve, and as a serious academic, I would have thought, with the reputation of serious academics, you'd be at a party full of celebrities, champagne's flowing, girls hanging off your arm, and instead you're spending it with an old fat bloke talking about a complete idiot. Where did it all go so wrong?
Well, those are like, days from the past. So yeah, no, they're sort of memories.
Okay.
But I won't mention when I'm in India what happens.
All right.
At the moment, I'm home with my wife. So
yes. Well, Happy New Year to her as well.
Yeah.
And thank you for allowing you to participate in this. So, what I thought we might start with. So, for those who don't know, Austin Whitsit and Leo Filius, someone I've never heard of before, had a debate in big quotes. On modern day debates this afternoon, our time here in Australia. And it was quite an extraordinary performance, and not in a good way. Leo Filius did fine, but Whitsit just sort of exemplified every flurf ever and why that no one should pay attention to them, basically. And Professor Phil Bell was there in the chat with me, and we decided we want to take this thing apart. So what better way to spend New Year's Eve than, talk about a complete idiot and why he was a complete idiot?
Well, are we on our own?
No, not really. But we're also going to hopefully teach you a fair bit of physics, because we got a professor of physics right here, and show the sort of things that Whitsit should have been talking about. Things based on reality, not just on things he made up.
Yeah.
Which is particularly exemplified by his answer to the question I asked him. So let's. I'm going to start. What I'm going to do. It goes for a while. The format of the debate was each side had I think it was a 10-minute presentation to make of their point of view on flat Earth, and Whitsit's. What I'm going to play is Whitsit's presentation.
Why don't we go straight to him?
Yeah, and let's. So at certain points, let's stop and then explain what really should have been going on.
Yeah.
So share screen. Share system audio, that one, and it's like 4 clicks. You think StreamYard to get it right. All right, let's play.
How's it going, everybody? Let me share the screen right here. All right. So I'll cover a lot of what he said. My little opener here. So we'll go to the slideshow. All right, you can see it?
Sure can.
Yes, now it's showing.
Cool. All right, so flat Earth 101. So before we get started, as this guy said, I've never even heard a model. We actually don't have to claim a model or a scientific model to actually use it.
That's not me. That's them.
But no one thinks that the Earth is a disk that floats around in space. No one thinks that the Earth is spinning around when they say that the Earth is flat. This is a straw man. So when ridiculed, it's actually ironically ignorant. So just to cover a couple basic parts of debates that should be known. Falsification is independent of replacement, meaning, of course, if something is proven to not be true or falsified, that remains a fact in and of itself. You don't have to replace it before it is not false or before it is actually falsified. The burden of proof is on the one that makes the positive claim.
Absolutely.
So shifting the burden of proof is the fallacy of
Earth is flat.
putting the burden of proof on the person who denies or questions the assertion being made.
Professor Bell, if you
Right,
want to
let's
interject,
stop there.
just
Yes, I certainly do.
Okay.
So right at the get-go, he said he doesn't have a model. Well, I find that extremely strange, considering him and his cohort are now expert navigators. I'd like to know where they
Sextants.
navigate. On what do they navigate if they don't have a model? Where do they go? And how do they know what's the distance from one place to another, or in fact, the direction of one place to another?
And especially distance from the pole in
Well,
nautical miles.
Oh, absolutely. I mean, I've done a bit of navigating myself, and I actually needed a map. You know, as much as I'm pretty good at geography, I still needed to have a map. So I'm just wondering which map they use. And how does the map that everyone else uses, which is like Mercator and the like, and charts that are projections of actual globes, how do they work? Very, very strange.
I think the answer is they don't.
Well, put it this way: the world isn't flat. I think that sums it up.
Funny that, yes.
Yeah, funny that, yeah. So the next thing he says here, he says falsification is independent of replacement. Well, I think that's just a way of trying to get out of doing any work. So I'd give him a big fat fail for that one. And I would say to him, well, you see, you're damn useless then, aren't you? Because what use are you if you've got no model from which we can make predictions so we can get on with our daily lives? Because we need to know stuff. So we need a model. Where's yours? Do we just give up and go to sleep, everybody, because we've got nothing to work with? So that just is total nonsense.
I always find it the most intellectually dishonest point of view to say that, oh, I don't know what it is, but it's not a sphere. And then, okay, well, what's your evidence for not being a sphere? And then you get something silly like we see too far. And that's usually, the response to that is, well, if the Earth was flat, then we don't see far enough, do we? So,
yeah, absolutely. And of course, I've got no problem with the burden of proof. If you say the Earth is flat, show us how it's flat, and make it match the reality. Actually, this afternoon. It's quite warm, and I thought I'd stay inside a bit and do a few little things with some with paint, and so I'll be showing you that a bit later on.
Oh, okay, that'd be nice. Yeah, but I think the reason he comes up with this burden of proof rubbish is that, well, not that it's rubbish, because the person who makes a claim does have the burden of proof, but the people on the globe site have met that burden of proof. All evidence points to a globe, and it's been scientifically verified, as Leo explains later on, not Elio, Leo, and
not the Leo either.
That's right. Yes, and once that's been met, then it's up to the other side to prove it's wrong, and they haven't. So.
I think that's fair enough. Let's go on.
Let's see what else he has other derp he has for us.
This is very important to understand because, as he's already done in his opener, he has shifted the burden of proof, and that is all that you ever get. So, for example, if this guy tells me that unicorns are real, then he shows me some CGI of a unicorn. He says, we have pictures of unicorns. I can't believe you don't think unicorns are real. And then he tells me, I have a book. And if I read my book tells me about this fairy tale world with giant octopuses and unicorns everywhere. And everyone agrees that this book is telling me about these unicorns that are real. If we prove that those unicorns aren't real, you're just reading some fictitious book that has nothing to do with reality. I do not have to give you some replacement unicorn or mythological character, then replace your little books and tell new stories about it before your unicorn isn't real.
Well,
can I point out the flaw?
The problem with that, Whitsit, is that we can grab a telescope and have a look at our unicorn, if you want to call it that, and it's flying through the air more than 10.9 times faster than an F-16 fighter jet. So you see, we can actually see it. We can actually see these things. So it's not quite like your unicorn where you'll never be able to see it.
That's right.
So I don't think they're equal.
And of course, it's something convenient for him, or at least in his mind, he thinks it's conveniently equivalent. So anyway, on with the stupid.
Right, falsifications independent of replacement. So what were we all taught in school? We were all taught the same thing, that the Earth is a globe. This is what we were all taught. So when people act like there's no debate, this is so ignorant, you guys are so
You know why we were taught the Earth is a globe? Because it's a globe.
Underinformed and uneducated. We were taught the same thing you were. And almost every single time, the person that ridicules the flat earther as dumb or ignorant doesn't even know a fraction about the Earth or the supposed globe Earth claims as the flat earther, which should be very telling to anyone.
Well, if the flat earther knows so much about the Earth, then why don't they have a model?
Yeah, well, not only that, you'd think that they'd use their common sense and they would not be a flat earther because they know so much.
Yes, but when you ask them for evidence, they run a mile usually. Or they do like Whitsit and just spout words at you. Anyway.
Anyone honest. So what is the positive claim of the globe, which is what we're testing? Claim number 1, the Earth is a sphere with a radius value of 3,959 miles and a supposed circumference of 24,901 miles. This is a positive claim, a shape claim of a sphere with a size claim, a dimension claim of a specific radius value. This is a positive claim. It has the burden of proof. Claim number 2, the Earth is supposedly spinning over 1,000 miles per hour at the equator while revolving around the sun 66,600 miles per hour on an axial tilt of 66.6 degrees. This is, of course, a positive claim of axial rotation. It has the burden of proof. Okay, claim number 3 is that this spinning magic globular Earth with a radius of 3959 is sitting in a vacuum of space that is encompassed in a near-perfect vacuum of 10 to the negative 17 torr. And this is a place that you can actually go to. This is a third positive claim. These are the 3 fundamental claims of the globe Earth. You have the burden of proof as a globe proponent to prove that this is in fact the case. So the heliocentric model has the burden of proof.
And you know what? We have proved that many
absolutely,
times.
Yeah.
You don't have to do much research at all to find it.
Let's see what else he says, and then we'll come back to
for all these
three silly things.
Okay, so that's just objectively the way that it is. We don't have to prove a negative. We don't have to explain any question you can come up with. The burden of proof is on the one making the positive claims, as the heliocentric model is. Wait, isn't saying the Earth is flat a positive claim? Well,
you bet.
Yes, it is. So you have the burden of proof, right? Flat is the description of a surface. Flat is not a shape. Okay, so we have the burden of proof to show that the surface of the Earth is flat, because that is our positive claim. Well, conveniently enough, this has been done numerous ways, and we can get into plenty of them. But radio waves can be sent over 10,000 miles with no Earth curvature obstruction whatsoever. How is this possible? Of course, it's propagating over a horizontal plane, 10,000 miles, no Earth curvature obstructing it whatsoever.
So he's never heard of the ionosphere then?
Well, I think he seems to think that you should be able to see 2,000 miles. So you'd be able to, I don't know, where see across some 2,000 miles of ocean then.
Yeah, you should be able to see across the Atlantic from New York to Dublin or something. Yeah.
Certainly be able to see some lights that far.
Yeah.
Well, I'm just wondering if we should cover these 3 points that he's made.
Go for it.
Well, let's just pick that last one first. That gas pressure without. They like to actually phrase it so that they say that you've got gas pressure next to a vacuum. Whitsit actually himself, he knows that's a lie.
Yep.
Okay, so he knows that is just flat out bullshit, because he actually does know what our model, the heliocentric model, actually says. So he knows that exactly. He knows that it's a gradient that just keeps going, getting less and less and less, and there is no point where there's some huge, vast difference between pressures. So it just gets thinner and thinner until at some stage there's practically none. And the reason it does that, well, I mean, gas particles start at the bottom. They've got kinetic energy. That's obviously, we know that's tied to temperature. And as particles get higher up, I mean, just if you throw a ball in the air, it's not going to keep going forever. I mean, there's some reason for it that stops, comes back down again. It's good old gravity. And this isn't a lot different to any other particles that have mass. Kinetic energy will take it up. Eventually, it just gets colder and colder. There's less and less of them, and gravity ends up being the main force acting on it, and doesn't go any further. What's the evidence for that? The evidence is clear. First of all, 99% of the atmosphere is below 30 kilometers. That should tell you something. And what's the evidence for that? Well, apart from the fact that you can measure it, you can see it. You send up a balloon, you actually can see the part that's blue, and you can see the part that's black. Well, if you were a flirt who was actually a truth seeker, you'd be asking yourself, why is it black beyond that blue band? Why is it blue up to that point and then black the rest of the way up? And why is there so much black compared to blue? Well, I think if you thought about it long enough, you'd say, well, probably because there's not very many particles of gas in the black area. And of course there isn't, because only just 100 kilometers, we have 0.000145 pounds per square inch, which is effectively a vacuum. So we've gone from the ground up to 100 kilometers, and within that space of that gradient, we've managed to actually achieve something pretty close to a vacuum. Now, why is the gas at the ground at 14.7 psi not rushing to where it's only 100, where it's only 0.000145 psi? Why aren't the flat earthers asking themselves this question? But you see, it gets worse, because they say there's a container there, and Whitsit will come across this again, and we'll cover it again. Whitsit keeps saying stuff like, the necessary antecedent to gas pressure is a container. He keeps saying that. He says, because you need something to press against. And he uses the word pressure, press against. Well, I'm thinking, well, if the gas that's on the ground at 14.7 psi can't be bothered going past 30 kilometers, and indeed certainly doesn't get much of it gets to 100 kilometers, why should it go any further where this imaginary container is? How does the pressure at the ground register pressure on something where it never goes anywhere near? Why does a flat earther not ask themselves this question? Okay.
Well, because they'll get an answer they don't want to hear.
I think that's pretty obvious. Yeah. What was the other thing he said? The
axial tilt.
Yeah. Oh, okay. Oh, he was talking about the rotation of the Earth. Well, I mean, and I think Leo covered that quite well, because Leo said that the Foucault pendulum's probably a good way, and there's obviously, we know about the laser gyroscopes as well, among other things. Yes, thanks to him. Which is the evidence that the Earth is spinning. But the great thing about the Foucault pendulum is that we actually have some of these in physics labs in various universities you can go to, and you can actually see them. They cost around, they're actually quite inexpensive. I think probably under $2,000. You could get one. They're made in China. You can get one. It's a Foucault pendulum, and it's designed to work in a lab. So they're only short, about 2 meters high. And they actually are designed to tell you very accurately your latitude. Now, why doesn't a flat earther answer this question? How does this machine with this pendulum moving backwards and forwards manage to tell you where you are on Earth? How on earth does it do that? What is this magic that this machine has, that it can tell you where you are, your latitude? However, we can actually model that with the globe, and guess what? It is not magic. It's not a coincidence. We can work it out. Do the same, flat earthers. See if you can come up with an explanation for why it works, and then give us a formula for it, like we can, because we can predict. We can tell you how it's going to process as soon as we put it down, if we know what the latitude is, or we can put it down, let it process, and tell you what the latitude is. You do something that good, I will be suitably impressed.
I always say that to flirts that I encounter on Facebook or anything like that. They keep saying, "Oh, what would it take for us to convince you that the Earth is flat?" And I'd say, "Just some evidence that's objective." And then that's when they run away.
Yeah. Let's carry on anyway. We'll come back to one of the other ones later.
Yeah. Oh dear, these big screens! I keep losing my cursor. There it is.
I'm wondering what the chat's saying. So maybe if you can keep your eye on it.
Oh, the chat? Yep.
Yeah.
Oh, they're saying you're awesome for a start.
Oh, gosh, no.
For hundreds of years and require the Earth be a horizontal plane, as you take an elevation angle to a celestial object, and then it comes down to the plane to have your corner pocket. An elevation angle is to a horizontal. You cannot in any way use a sextant successfully without the Earth being a horizontal plane, and it's worked for hundreds of years for hundreds and hundreds of miles.
I think it's so stupid that they think for some reason sextants prove flat Earth instead of the exact opposite.
Yeah, I actually love this bit on so many levels. It's amazingly funny. Apart from the fact that they now have a model, because as I said before, what are you going to navigate on? Where you're going to navigate to, and how you're going to know where you are if you don't have a model, but you have a sextant. I mean, what is the point of having a sextant in your hand if you don't know where you're going with it? So, obviously, you do, because they know that you can get your latitude, and then you can work at three different points from that, 3 different stars, and you can actually fix your location. You can move north, south. You can do it again. Find your latitude, and the difference between them will be 69 miles for every degree that you move north or south. They know this. So if they know how to navigate, how can they not have a model and know how to navigate? There's a conundrum. Why will any flat earther who's pondering whether or not to be a flat earther ask themselves this question first?
Well, yeah, they think the sextants work, but if you don't have a model, what are the principles that are built into the sextant to make it work? So if you don't have a model, how do you know the sextant actually works? And how do you know it doesn't work on a globe? So there's so much that depends on them getting it right the first time, and that's the bit they ignore. Well, they just want to have the argument sometimes.
Yeah, I think so. So the other night I came across Sleeping Warrior, who had a little tete-a-tete with him, and basically I said to him, when do you think everybody's going to turn in all the manuals, the sextant manuals, all of the navigation manuals, change all the courses and remove all the references that say the Earth is a sphere? Because there is no sextant manual. There is no course. There is no navigation course. There is no navigation manual. There is no almanac that does not say that the Earth is a sphere. So when are you proposing that they will change all of this stuff to match the flat Earth? And then we need a map that matches it. Sleeping Warrior's sleeping on it.
I wouldn't ask him to tie his shoelaces. He'd accidentally kill himself or something. But yeah, just to evidence what you were just saying about sextants and the globe, I was talking to Arctic Reflections this morning, and he's a sea captain. He's well versed with sextants. And
I watched that. That's good.
Yes, and he was showing. I showed a video of his where he showed the manual from which he learned about sextants. There, it was clearly assuming Earth was a globe. It was all in Swedish, but you could see the globe. You could see the trilateration. As Mr. Sensible explained it, not the way Mitchell explained it. or Flatsoid explained it. So yeah, it's the whole principle of a sextant is it can only work on the globe. Now they have the argument that they think a curve you got to need a flat baseline. You can't have a curved adjacent. You don't. All you need is a horizontal. You don't need. It doesn't matter if the Earth is curved, and because the Earth's so big locally, it's effectively flat anyway. That's why you think it's flat because it looks flat.
But make the slightest bit of difference.
Yeah. So sextants work on a globe either way. So it's just as I said before, they're just making an argument because they want to make the argument and convince people even dumber than them, which is the sad bit.
I think it comes from a misunderstanding, and quantum eraser, I think, might be a principle to this misunderstanding. And that is, they think that when you take the reading, the elevation reading, and you take a horizontal from it, that horizontal is at the water level and goes all the way to the GP. So in other words, you now use that all the way to the GP, and that is the distance to the GP. So they're using that. So they've now built a triangle, if you like, which of course is absurd, because if you know the angle and you know the distance along, you now know the distance to the star, don't you?
To its ground position, yeah.
Yeah, I mean, no. Well, you actually can calculate the distance to the star. If you've got a triangle, you've got the angle, you've got the base, then you can use trigonometry to the tan of the angle of that angle will tell you the distance to the star. It's absurd, and of course that doesn't work for in reality, because I mean we're talking about practically parallel lines from both points of view. So therefore, what are you going to do? Find the tan of 89.999999999 degrees?
Yes, you've got to get that pretty accurate to get the accurate distance. So.
Yeah. It absolutely is absurd. It doesn't make any difference. So we're not interested in making a triangle all the way to the GP. All we're interested in doing is finding what's horizontal. Hold your sextant horizontally. If you know how to do that, you don't need to do anything else. If you've got a bubble in your sextant, you can use that. If you don't know anything else, and quite often you're out at sea, you can't actually make out the horizon. It might be like 5 or 6 o'clock in the morning. It's not crisp. There's some clouds down low. You can't really make out where the horizon is, so you can't use it anyway. So you've got to find other means of getting your sextant to be, pretty level, horizontal, and then take your reading to the star, to the sun, wherever. Well, it won't be the sun at that early, but to a star. So once you've got that, then refer that to your almanac, depending on where you are.
And the almanac itself will say it's based on a globe as well. So
yeah, and that's all there is to it. This isn't rocket science.
It's like they were too scared to find out the truth, so they only studied it as far as they heard something that they liked, and then said everything else doesn't exist. But everything else is what proves you wrong. So why wouldn't you even look at it?
Yeah,
or they did look at it and they're deliberately lying about it.
Yeah, do they cringe? Do they cringe when they come to the part that says that it's a globe? They think, oh, it's all good up to here, and then they screw it up. They screw it up after this. But nobody ever stops to ask, how come they don't all get lost if they don't know what they're doing?
Well, I'd personally like to put Whitsit and Nathan Oakley and maybe a few others in a boat in the middle of the ocean, give them a second and say, off you go, fellas. So we'll see you when you get back to port.
Actually, I think Wolfie has a challenge with a bit of money behind it.
Yeah, about $4,000, I think.
They can, if they can actually do some navigation. Maybe. So yeah,
if you're a flirt watching this, go to Wolfie's channel and look up that challenge, and you might make yourself a little bit of a nice little earner. If you get it right.
Some really nice dollars there.
Yeah, $4,000's not these days. That'll buy a few bottles of whiskey.
Not to mention the kudos, not to mention the bragging rights that would go along with having destroyed Wolfie, Yeah.
Wolfie's got 70,000 subscribers, so it's not like he's a minnow.
There you go.
Anyway, we
could
better
have a
keep
fun-
going.
I could have fun with
Otherwise,
that.
we'll never get through this.
Yep. Okay, keep going.
X horizon has been seen over 10 times the geometric limitations of the globe. This falsifies the globe claim. Again, there is no need for replacement of this model. It has been falsified. The entire globe model depends on the accuracy of this claimed radius value. Everything. So this radius value has been falsified. So welcome to flat Earth. This is not real, and it's okay. You made the positive claim that this is real. We have falsified that positive claim by falsifying the radius, and you have the burden of proof to substantiate your claims. We must not come up with some fairy tale to replace it. So that is where it all begins, to be intellectually honest about the conversation and where we are. And cool, excited about having a discussion.
You got it. Thank you very much, Austin, for that opening statement. And with that,
So I'll stop it there. I'll look up the next interaction.
Okay.
All right, so it's almost an hour later, actually, but it's a good one. Where's it start? Yeah, just over the hour mark. Back a touch. There we go. We'll do it from there.
It is talking, to be fair, because I don't want Whitsit to do the same to you, okay?
So space-time is conceptual, right? So space, the idea of emptiness, nothingness, a privation. Time is a quantification method that we use to quantify passing. We put it into a coordinate system, right, using breadth, height, width into quote-unquote space to determine this effect of a gravity well, and that gravity effect is the bending and warping of space-time. Anyway, on its face, it's inadmissible.
Did I just hear him admit that gravity exists?
Well, he seems to be trying to describe general relativity. So let's see what he says.
Well, I did want to ask you. He said that space-time is just a concept. Is that the way you would describe it?
Well, I mean, if you want to call it that, it's fine. I mean, that's the model that Einstein came up with in general relativity, and it's a model. I think it's important to understand what a model is. And this is a way of describing some phenomenon that we have and saying, well, does this explanation give us some predictability value? Can we use it for something useful? And if the answer is yes, well, go ahead. Can we break it? So we're going to try and break it. In other words, what are its limitations? Let's take, for instance, Newton's model. Well, practically anything that we do that's relevant to classical motion, we use Newton's model. It's easy to use. The formulas are simple, and the results are accurate. The results are accurate enough for us to be able to do the jobs that we need to do.
Well, the vast majority of them, yeah.
Yeah, for almost anything we do. And then, again, one of those things that Sleeping Warrior was arguing last night. In fact, he called me a child abuser.
I was about to ask if he called you that.
Yeah,
he calls everyone that.
He called me a child abuser because he says he's accusing me of teaching Newton's laws to the engineers. I'd like the engineers to say that I'm a child abuser, but anyway, so he's accusing me of teaching Newton's laws, and I'm thinking, well, so what do you think the engineers should use? So let's say, for instance, we had engineers who were doing aerospace, and let's say ballistics is one of the things that they have to cover in that, and we'll certainly have to do with rockets and stuff like that. And we'll say, all right, well, there's a very basic formula that you'd probably get in high school: S equals UT plus half AT squared, and you can replace the A with a G. So S equals UT plus half GT squared. Well, if you use this form, what would Sleeping Warrior or any flat earther or Raichi or any one of those who think that density and buoyancy explains gravity, could you please replace this formula with something else so that the engineers can use it? Is there some formula that you can replace? The engineers can use it so they can work out the length of a beam across a the span of a beam that will hold up the roof. I mean, these are just basic things that we have to know, and we use Newton's laws to be able to do them.
Yeah.
How else would you do it? You'd have everybody trying to learn Einstein's field equations and being able to derive them all the way back to, something simple like F equals mg? What for? That works perfectly well. Anyway.
Yeah. Because you can't get the downward force on a beam from density, can you? So,
how?
Of course, density has even if you took gravity out, then it wouldn't be density anymore. But anyway, let's move on.
Yeah. I mean, of course, the density of the beam does come into it, but not for that reason, right? Gravity has to be involved as well.
Microraptor says everyone talks about buoyancy. Well, what about girlancy? Yeah, that's a blow for equality. There we go. All right, let's see what how Whitsit. So what's going to happen here is Whitsit's going to just spew some garbage. Yeah. Leo's going to respond, and he responds quite well, and you'll see why he makes sense. And then Whitsit gets triggered by that somewhat. So he's like a bullshit vending machine. When you say certain things to him, it just pours out of him. So this is a good example of that. It goes for a couple of minutes, though.
Conceptual abstractions cannot in any way have physical properties. It's also fallen apart as early as the 50s. The galaxy rotational speeds debunked it. Also, as recently as modern times, we now have dark matter, dark energy making up 95%. That is not accounted for in relativistic application, and it's off with 95% of its occupancy claim. So it's not even close to being viable mathematically yet, and none of that even matters. It's all begging the question. Because on the local scale on the Earth, you never account for gravity, you never account for spinning, and you never account for Earth curvature. This is just objective, and we need scientific evidence before we...
He's saying we need scientific evidence, but he's spouting out a whole lot of things that for which he's not substantiating and which are actually wrong. We do need gravity. We do need curvature of the Earth and so on.
Well, he said that we don't account for gravity. I mean, simple drop a brick on your foot. see what happens. See which direction the brick will head.
Well, based on what he's saying, if you drop one on his head, it won't make any difference.
Pretty sure of that.
But yeah, and then he gets into the fallacy thing. Oh, this is a fallacy. That's a fallacy. Blah 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 blah. And
yeah, I think eventually when they do get cornered, they start using semantics, and quantum eraser is pretty good at doing that. As soon as he gets cornered, like he'll say, well, what's mass? If you said, well, that's mass times, force is mass times acceleration, he'll then try to head you down a rabbit hole so that you can define what mass is. And the whole point of that is to deflect completely away from the actual argument. Yeah.
Also to make you lose your train of thought.
I think so. Yeah, and of course, he'd love for you to say something he'd love to misquote you, or to even get you to say, to misspeak.
Yes, which is because he's learned this all off by rote, obviously, because he's just spouting it out. There's no understanding behind the tone of voice or anything like that. So he can say it perfectly, but he knows everyone else is trying to think based on what they know rather than what they've learned off rote.
Actually, I've done some careful analysis of what he says, and I'm convinced that he's actually subpar in terms of intelligence compared to many of the other flat earthers that he even talks to. So I think he just struggles through and uses his rudeness to cover that up. I don't think he actually has much going for him in the grey matter.
Yeah, it's certainly it's called bombardment persuasion, where you can just, if you throw all this stuff at someone, they think, oh, wow, I don't understand any of that, but he must know it because he seems so adamant and he seems to be able to say a lot about it. So therefore, he must be saying the truth. And that's how you get followers to these sorts of people.
Well, he uses actual people with credentials to push his points along. So in other words, he's by cherry picking what they say. and doesn't even read any further. Like he might cherry pick something in a sentence, and not even a sentence later contradict what he's actually the point that he's trying to make.
So let's keep going.
I believe cartoons from governmental agencies. So we need actual physical
conspiracies. Yeah. It's ironic he asked for evidence.
Yeah.
Am I good, Austin?
So Leo does a good response here.
So a few things here, and I promise this is all going to loop back to how we know that the Earth is not flat, that it's a sphere. So the first thing is, you said that space-time is this conceptual thing. It's not, and ultimately this gets into a lot of philosophy of physics, which I really don't want to get into, and I don't think the audience is really interested in getting to. But if anybody would, I would just recommend looking up things like relationalism versus substantivalism with respect to space-time, and it's the ontology of space-time. In fact, this is a thing I've been reading on a lot in the past couple of days, because I've been doing a lot of reading into things like structural realism and ontic structural realism and relational quantum mechanics and other areas of metaphysics. So this isn't something that's new to me. There's a huge philosophical discussion being had on this, but even substantivalists, relationalists, both would and every physicist I have ever talked to in my life would reject this idea that space-time is purely conceptual. It was proposed not in 1905, but in 1915, at least general relativity was. Special relativity was published in 1905. And Sir Arthur Eddington actually observationally confirmed general relativity in 1917 when he observed two stars that were supposed to be behind the sun, that are behind the sun, but he observed.
Yeah, was it 19? Because I thought it was 19.
I think it was 19, yeah.
Okay.
Them out here as a result of the what's ultimately a shear through the dimension of time, which is how we know that time is actually a real physical fundamental dimension, because it can actively be sheared by the stress of mass energy as described by Einstein's field equation. So he measured that, showing and the amount by which their trajectory was off as a result of the curvature in space-time was precisely what general relativity had predicted. General relativity has never once failed any test that it has been put to. It isn't a complete theory, but that doesn't make it a wrong theory. The reason all of this matters is because, again, I'm making a much broader argument here, not just that the Earth is a sphere, but how we know that. And we know that through a set of sound methodologies that all scientists across the planet utilize, and that all of these methodologies obviously give us accurate descriptions and ways of understanding reality, because if they didn't, none of our technology, the very technology we're using to have this debate, this discussion right now, would work. And so if we can trust them in other areas, why wouldn't we trust them here? All of this science shows that the Earth is a sphere, that it rotates and it orbits the sun.
Yeah.
Now, to be fair, yes, but to be fair, though, I said Whitsit hadn't substantiated any of his points. No. The only substantiation in there was the Eddington experiment, but that should be enough, because that confirms that, first of all, gravity exists, that Einstein's got valid things to say, and so on. And,
well, if Whitsit disagrees, he should just point out, look, I disagree with that point that you made, and give you a good reason for disagreeing.
Yeah, but that was one piece of substantiation more than Whitsit, though.
It was.
I've got a super chat from the Triggered Limey for £5. Thank you very much, mate. Happy New Year.
Thank you.
Loving the stream, mate. I'm a big fan of both yourself and Professor Bell. Wishing you both a very happy New Year. Well, happy New Year back to you.
Yes, back at you too. Yep.
All right, on with the stupid.
So you cannot provide any substantive specificity of empirical evidence. You just keep making claims appealing to tech.
He just did with the Eddington experiment.
Yeah, he certainly did.
You weren't listening.
Technology, an accelerometer must prove that the Earth is a globe and that gravity bends and warps and physical properties can be attributed to concepts. Because I have an accelerometer in my cell phone, the electrical grid uses nothing to do with the Earth being a globe. None of our technology does. You can't fly a plane, you can't fly a car.
Let's stop him there for a second.
What the hell was he saying?
Well, he made a claim that there's an accelerometer on his phone, which is correct. What does he think happens? Why does, if you drop your phone, the accelerometer on that phone will work? If you move your arms, up and down, it'll work. Why does he think that happens? He's admitted that there is such a thing on that, and he's saying that we would say that gravity's. He'd say that gravity doesn't exist, and yet knows that when you drop something, it accelerates towards the ground. Why does it do that? And how the hell does buoyancy and density or disequilibrium, whatever that is, how does that account for things accelerating when you drop them?
And how does an accelerometer pick up buoyancy
What does it know?
intensity?
How does it work? What exactly is there in an accelerometer that makes it work? Explain to us how all these things work. Explain to us why a gravimeter works. Why is it that you can take it out into the field and discover some iron ore or some other elements that are below the ground, because in that particular spot gravity is greater than somewhere else? Why is it that this gravimeter actually does work? Why does it?
And they can't explain it, so they try not to.
Yeah,
they just change the subject,
Yeah, and I think you would find that they're patently not interested in actually finding the facts, because they'll do everything they can to obfuscate.
Yeah, they're just not honest.
No, it's a silly game. I can't put it in other than that. It's a silly game in which there are some genuinely silly people.
That's actually one of the best ways I've heard that expressed before. It's a silly game, because that's what they're doing. They say, "Oh, you can't prove it," and we give them all the proof, and then they come up with these bullshit arguments to just dismiss it all. For them, it's a game, and they're just playing. For them, it's fun, but they can hurt a lot of people because they lead them down paths. Like Raichi is a good example. Lead them down paths which can lead them to actually dangerous paths, like anti-vaxxing, 5G, all that sort of stupid nonsense.
Yeah, but for the gateway sort of thing, it wouldn't matter. If you want to believe silly things, people have believed silly things for a long time. There's people actually think Loch Ness actually exists. So
people believe silly things since people were around.
Yeah, absolutely.
It's part of human nature.
It's not a big deal that they do, but it is a big deal if they decide to homeschool their kids and then remove their opportunity to maybe get involved in STEM, later in life.
To be the best person they could be. Yeah.
Well, imagine somebody who homeschools. Imagine one of those flat earthers homeschooling their kids till they 15 or 16. This is when you'd expect them to be doing VCE or preparing to do their VCE or their high school certificate. That's when you'd expecting them to do that. How on earth are they ever going to do that? I mean, those things are not that easy. Like high school certificate mathematics, for instance, physics, chemistry. These are not all that easy, these subjects, even at that level. How are they ever going to get their kids have an opportunity to do that type of work if they've been homeschooled by someone who can't even figure out that the earth isn't flat?
I'm hearing the professional educator talking here right now of many years standing. Tiny Captain says, to address to you, Professor Bell, their claim is because things go down.
There you go.
And Nimrod replies saying, "Oh, gas go down, go boom boom."
Yeah, well, yeah. I mean, I've got quite a few things that I could show you. I've actually got I'm not sure how easy it would be for me to put it up to share it, but I've actually got somebody filling a cup with. Actually, no, there's some dry ice in a cup.
Yep.
Okay, and you can see the dry ice coming out of the cup and then heading towards the ground. I think, well, there you go. There's some gas that's heading towards the ground. So it's obviously affected by gravity.
Yeah. Do you want to play the video?
Yep. Keep going.
You see the share button down the bottom of the
screen? Yeah. No, I'd have to. You keep playing their video, and while you're doing that, I'll kind of just look around.
Okay.
Make sure that I can get it. Yeah.
All right,
if I see it easily, then I'll do that.
All right,
But I mean, I've got some really good stuff that you'd be interested in looking at.
All right, good. We've got another minute of Whitsit here, so let's do that.
Yeah,
None of
yeah,
that is real. Just this vague claim, void of specificity. So you can basically appeal to majority or consensus, appeal to authority and credentials. And this is insufficient and in no way admissible in intellectual form. We need empirical evidence. There is no empirical evidence of Earth curvature, no physical measurements of it, only physical measurements falsifying it. You admitted that you didn't know the radius, didn't know the curvature rate, didn't know where it should be seen, and you didn't know how it was supposedly measured. You then said that if the radius was falsified, it wouldn't debunk the globe. Well, every single person with any knowledge or competence on your side at all would tell you that you're patently wrong. Then I asked for scientific evidence for axial rotation, yet to get any whatsoever. There is none. Just pointing at the sky and saying, I think that's what it is. Believe my story. This is how you can apply my story. It's called a begging the question fallacy. It cannot be invoked to prove the very thing you are claiming to prove. That is very fundamental, rudimentary fallacy. So there are the two primary things. Of course, the third one being you can't have a pressurized system adjacent to a near perfect vacuum of 10 to the negative 17 torr. The second law of thermodynamics would not allow that. So there's your three core claims, and they cannot exist. They've been debunked.
Well,
yeah,
let's address that nonsense that they keep talking about, the second law of thermodynamics not allowing for that to happen.
Thermal dynamics, haven't you heard them?
Yeah, yeah. So
they must be right.
Yeah, so I've actually seen them use a demonstration by a professor or a instructor where he's got flasks that are joined together, and then there's a valve in between. On one side he's got bromine gas. Well, bromine's a liquid until you warm it up, and then it becomes a gas. So therefore it's got a reasonable amount of kinetic energy going on there because it was a liquid. And then open up this valve, and as a result of opening the valve, the gas shoots off and fills the near vacuum that's on the other side. Of course, it wouldn't be much of a vacuum on the other side, given the fact that we're talking about some glass. So anyway, it moves across, and then this professor says, "Well, there you go, no energy change," and he's actually describing a model for the second law of thermodynamics. What he's doing is describing a model for the second law of thermodynamics. That's what he's doing. He's showing us, have a look at this. Imagine that you've got order on this side, and we allow it to go into a system of disorder on the other side. So you're moving the gas. We're moving the gas from one. Imagine that this is energy. Okay, so to say that, well, okay, if he says there's no energy change between this particular flask and that particular flask, if you actually forget that this is a model and then say, well, that's the reality of what he's saying, well, that's nonsense, because you are moving the gas from one place to another at this particular one where the gas was quite energetic because it was confined before the stopcock, and therefore E equals half mv squared. That's energy, kinetic energy. These things would be bashing around at the container and amongst each other. Those particles would be hitting each other. When you open it up, they've now got twice the volume for them to move around in. So there's definitely going to be an energy change in terms of their velocity than there was before. It might be minute, given that's such a small much, but there will be an energy change. Is there an energy change from the outside? Of course there is. This is a glass. This is a glass gas flask. Of course, there's going to be some energy change from the outside. He's holding on to it. He's adding energy to it just by holding on to it. So if you want to get pedantic, that's just nonsense. This is not in an isolated system. What the second law of thermodynamics is very expressly, in the very first sentence, describes this as being in an isolated system. Isolated system meaning it's isolated from energy coming in, from energy going out, and also from matter going in and from matter going out. And the only thing that I can think of that you would describe as an isolated system is the universe itself. So now, if they completely misunderstood this fact, then let's have a look at the reality. The reality is there is a pressure gradient. At the atmosphere, 99% of the atmosphere remains below 30 kilometers, just 30 kilometers. So even balloons that go up to 38 kilometers, like Mr. Sensible's balloon did, are going beyond that point where there's very, very little gas at all. And in fact, I think he actually measured the pressure at 38 kilometers. It was extremely small. Well, by the time you get to 100 kilometers, there's practically none. And at that stage, it's effectively a vacuum. Now, if you're going to say that the second law of the thermodynamics warrants that the gas will move from a high pressure area to a low pressure area, for that reason, why isn't it doing it? Is the second law of thermodynamics asleep? There's obviously things that are affecting this so that it doesn't do that. And that is simply two things. One is there isn't an infinite amount of kinetic energy, so it's going to run out of kinetic energy, and it gets colder and colder as you go up there. Kinetic energy is tied to temperature. Heat, for instance, Q equals mc delta T. Does he not know this simple formula that I think they probably learn? I would imagine they would learn that in high school. I'm pretty sure I learned it in high school. Pretty sure I learned about kinetic energy in high school too. So what about kinetic energy? E equals half mv squared, and E equals mgh. So that half mv squared is equal to mgh. How about that connection between energy? So kinetic energy going up ends up being gravitational potential energy, as it can't go any higher. All of those things are defeating this second law of thermodynamics, if that's what they're claiming is going on over here. And again, if the gas is not going to get any further, it can't even bother to get up to 100 kilometers, why does it need to go any further? So in other words, what the hell do you need a container for? Okay.
Yeah, one of the things FLIRFs don't seem to understand is the summation of forces. That when there's more than one force on something, you know, things like the gas being held down to the planet happen. They seem to think, like they imagine that, oh, hello, Eileen Dover. They imagine that bromine experiment, which was used by Sleeping Warrior in one of his videos to say your model's dead. Anything he says, it's automatically wrong. And they just imagine gas should just fly out into the universe. But they're completely ignoring the fact that there's gravity there to hold it there. And I thought up a good analogy for it. It's like clouds. Clouds are the barrier between, where forces of evaporation and buoyancy, which is based on gravity, that cloud line, that's where that all comes together. Similar things like the tree line or the snow line on mountains. That's where the temperature is the right temperature for the plants to grow or the snow to stay frozen. And that's what happens in nature all the time. And it's the same with the atmosphere. There's a point where majority atmosphere, you were saying under 30 kilometers, most of the atmosphere is under that line because gravity keeps it down. Some of it's more energetic, as you were just giving us a lecture on, and it goes further. And the lighter the material, like hydrogen or helium, that goes all the way out past the moon, but it's still in orbit around the Earth. So it's technically part of the atmosphere. But when you say, oh, the atmosphere extends out past the moon, they're thinking you can breathe it out past the moon, but because they just can't grasp the concept.
I think there's amongst them are some dishonest people, and Oakley will be one of them, who says something like, well, now that they say that there's atmosphere beyond the moon, therefore the moon is in our atmosphere. Therefore, all of the things that they claim about the moon, being in our atmosphere is, must be true then, because never mind that the moon is 400,000 kilometers away, of course. But I mean, look, we will get to some of that later. I've got something really good to show you with respect to how the moon and not particularly the moon, but the sun goes around, and I'd like some flat earthers to actually explain what's going on.
We always like them to explain things, but they never do.
No, they won't. But you know, it's people like people in chat and stuff like that can pass things on. For instance, I hadn't put out a video for, I don't know, for a year or so, you know, and then I put a video out, you know, debunking some stuff that Quantum Eraser did, and I had 1,704 or something, no, 1,710 subscribers. I lost 10 subscribers from that video.
It's supposed to work the other way.
I know. I'm thinking, what the hell have I said?
I think a lot of it is YouTube gets rid of inactive accounts that have been inactive for a year or so. So
Okay, yeah.
some of it's that. Speaking of subscriber count, I am currently on 1,660 subscribers, and I would like to get 6 more, just so that I can flash that number of 1666 around to all the flirts.
Oh, okay.
So if you can share this stream or any of my videos and see if we can get a couple more, and I can screenshot that number as it goes past, and yes, I'll show that to any flirt who's interested.
Well, I've got 2,000 as my gain. Actually, I did mention it in one of my videos, but I am planning to retire. I think I've done enough. Sort of.
Retire from YouTube or?
No, retire from work, and so I think I'll still have a hand in doing some lectures, but I'm not going to be full on because, you know, that involves administration, and I'm just so sick and tired of doing that sort of stuff, you know. And so if I can go in and somebody can say, look, rock up for a lecture on this. You don't have to do anything more than talk and then leave, you know, and other people will handle, you know, who was there and what they were doing, and tutors can handle, you know, assignment work and stuff like that. Then I'd be happy doing that kind of stuff. But to go full on, you know, it's I'm just nearly 70 and just had quite enough of it. So I'll be retired. So, but I'm not going to give up altogether, because I do want to. I've got a second channel, and I do want to actually do some serious teaching on it. I want to help
Professor Dave,
but I want to bring it down a little bit. I want to help sort of high school kid level, you know, probably GCE and, you know, year 11 and 12, that sort of level, and help them, you know, get interested in STEM subjects. Particularly if you can get, there's just not enough girls who are interested in it. See if we can get more of them to be interested in it. There's certainly not enough women engineers around.
It is growing.
It is growing, but not as fast as it should. Because what it means is that there is a perspective that we are missing out on from that point of view. So I'd like to see more of that. So I want to try and do some of that, and I love teaching. So, you know, I'd like to do some of that.
You've done it all your life.
Yeah.
Yeah, you couldn't expect you to stop, but yes, if you want to get rid of the admin, YouTube's probably a good outlet for you to do your retirement. Yeah.
Well, my doctor specifically said, you're not allowed to stop. So you got to keep doing something.
Yes. Oh, definitely. There's no point in sitting in the chair all day.
You got to keep your mind active. So. Yep.
And you heard it here first on the Huge Ass channel that Professor Bell is going to retire. Scoop for Huge Ass. Speaking of Huge Ass, the question I asked to Whitsit, that's what I'm going to play now.
Yeah, sure.
I've got to go back to sharing, share audio, and there we go. All right, let's listen to my question. And Microraptor says that she thinks Phil is probably too much of a science nerd to ever stop completely. Yes?
No, can't stop completely. I mean, actually, I'm working on a project. I can't give too much away, but there's a paint. There's a paint that if you use reduces the temperature or keeps the temperature down by about 10%. So if we can save 10% on energy, because
Yeah.
because of some surface material that's pretty good going. So I'm
In,
working on
in
that.
warm climates like Australia, yes.
Yeah, exactly. So you can, you know, just think about all of those miles and miles of sheds and houses, and you know, they just now they're talking about changing the, making sure that new houses have light-colored roofs.
Yeah.
Okay, so that because it didn't make any sense at all, the red roofs and especially the red ones, and then the black ones are even worse. So that didn't make any sense at all. I don't know why anybody chose red for a roof, and so why not choose a white roof, you know, or something that completely reflect all of the energy.
Yeah. Well, the problem is it might reflect it into the windows of the neighbours, but you can do that through roof design.
Well, this particular paint goes even beyond, almost at the level where that an actual mirror would do. Okay,
Wow.
So yeah, it's pretty good.
All right. Well, we'll look forward to hearing about that.
Yeah.
So let's hear more from Whitsit, unfortunately.
It's okay.
Oh, what happened there?
Why can I see the south celestial pole any clear night from my home in Australia? How can there be two celestial poles on flat Earth?
There isn't a celestial.
I love this question.
You know, all you're doing is all. Listen very carefully. All the stars in this.
The arrogance of this guy. He's saying, "Oh, you're a dummy. You don't know. I'm going to tell you what you don't know."
Let's just listen to him actually just talk absolute nonsense.
Yeah.
Sky, all of them. They all go east to west. Clockwise and counterclockwise are nothing more than apparent locations or apparent rotations. They're not the same as actual directions. So there's the answer. You're conflating the two.
Okay, so this I might actually just share something now. Okay.
Yep, I'll stop.
All right, so I just hit the share button and
actually then you select the screen. Yeah.
So first I'll get the screen up and then I'll hit the share on that so that I get that.
And if it has sound, you've got to click the little audio button.
No, it doesn't. Yeah. So I'll just let me just find it and bring it up so that I've got it, and then so just bear with me for a moment.
The wonders of the sea mage, eh?
Yeah. I wish I was better at this stuff. I've now got to turn this into. Okay, I did extract all of this.
A better roof design would be grass. I'm not sure that it works so well in Australia with the rainfall we get, because as soon as it rains, the roof would be twice the weight. So you'd have to do some engineering to make sure your house didn't collapse on top of you.
Yeah, exactly. Yeah.
There's some things here. Dora says, just put solar panels on your roof. It keeps sunlight from it and generates electricity. I can imagine painting my south wall with a highly reflecting paint.
Absolutely right. That's perfectly right. So if you did
that, she means north wall.
Yeah.
I know she's in the other hemisphere. I'm being facetious.
Okay, so here we go. Where have I got it? I thought I had some star trails here.
Well, I've got a video like that.
Have you got the I don't want a video. I just want one picture. One picture. I just want just so I can talk about it. Yeah.
Yeah, I don't have one picture. I have a video.
It doesn't matter. A video is fine. Yeah, so you can play.
Well, it's a time lapse. Yeah.
Yeah. No, that's fine.
I've got to find it now.
Yes, it would be. Yeah.
Let's go back. Yeah, hang on. Oh, hang on, I'm in the wrong one.
Choose that.
Sorry, I should have had this ready. Should have known we'd be talking about it. That's not it. Oh, I need another page.
Well, actually, I've got mine here, so I'll just put it up.
Well, you go then.
I might be quicker than you then. Okay. So here we are. That's you. And so I'll share. So this is I haven't used Streamlabs before, so this is a new thing for me. So just share a screen, I take it?
Yeah, select the one you want to share. And I just found it, of course.
Okay, window. And I think that's the one. What have we got there? Okay, that's something like that. I don't know if you can see that. Is that
There we
sharing?
go. Yep, it's there now. It's a bit small. Can you zoom in a little?
Yeah. Okay. Yeah. All right. So, okay. How's that?
Yep, that's better.
Okay. All right. So star trails, and they all look similar to this. Okay. Well, let's just think about it when we're looking at this. This is very, very close to the horizon, isn't it? Yep.
Yep, this is obviously in the northern hemisphere.
Yeah, so in the north, and it's very close to the horizon. So you would imagine you'd standing somewhere close to the equator looking at this.
Yep.
All right. That's not far from a perfect circle, wouldn't you say?
Yeah.
Okay. Why isn't it oval?
Why would it be?
Well, let's say, for instance, you were, remember, this is going around the North Pole. I'm talking about a flat Earth, okay?
Oh, okay.
This is going around the North Pole, right? This is at above the North Pole. So you look, the only place you'd ever see it, a circle like this, is if you're looking directly underneath it. Let's say, for instance, you had a light fixture, a circular light fixture, and you stood underneath it. It looked like a perfect circle, wouldn't it? What the hell would it look like if you backed away from it?
Yeah.
Wouldn't it look like an oval?
If it was close.
Imagine if you backed away so far that it was practically at your horizon. What would it look like then?
It should be sort of all stretched out.
Almost like a straight line, wouldn't it?
Mm.
There's only one way that you can get this star trail look like this. A globe.
That's fascinating. I hadn't thought of that one before. That is definitely a flat Earth killer.
100%. Dead in the water.
Yeah, because it doesn't matter where you are on Earth, you'll see the same thing. And on flat Earth, you shouldn't see the same thing because it's supposed to be close, only 3,000 miles
an oval. Exactly. It's got to look like an oval. In fact, it'll get more and more acutely oval the further and further you back away from it. It gets worse. How come you can get something like this in the south? Because remember, all the stars are going around the single point. All of them, even the ones that are around as far down as Antarctica, are all going around, supposedly on a flat Earth, going around the single point. So
I can show you that.
How the hell can the ones in the south be producing something that looks like this? What direction are those stars going in order for that to be the case? That is another flat Earth killer. Stone dead.
I'll just show the southern stars and their rotation, in fact.
So I'll just stop sharing.
See? Okay. Oh, it just does it automatically. So as you can see, they go clockwise in the southern hemisphere.
Hang on, for some reason or other, I'm not seeing that. But,
you can't see that? Okay. I'm seeing it on the stream. So let me try it again. You're right?
Yeah, no, I'm good. I'm still seeing the one that I put up there. So,
because you probably haven't. It's a window, probably.
Of course.
Yes.
Of course it is.
So I'll play it again.
That helps. Yep. Yeah. Okay, I can see it now. Yeah.
Yeah. So that's the southern stars. That's from my backyard at my old place. You can see the moon coming in the top corner.
Yes.
And just keep replaying it. And you can see Sigma Tantus is very hard to see, but actually I'll just stop it here. Over here is the Southern Cross. You can see that's the top, that's the bottom, and if I just started it,
fantastic.
Do it when it comes back, and I'll stop it on the first
beautiful.
frame if I can. Yeah. So you can see the Southern Cross there. There's
okay.
Cross, and the pointers over here, the two there.
This 100% looking at this kills the flat Earth, because there's no way for the flat Earth to move, or for the stars to move so that they'll look like this on a flat Earth. How? They're supposed to be going around the North Pole. And don't tell me we're giving you that we're building up a straw man to burn down. You must have a model. You use this for navigation, because you guys are all experts at navigation. So you can't have your navigation and then not have the stars. Pick one.
Yeah, especially if you're out at sea and there's no landmarks.
Exactly. So that's why I quite like this question about the star trails. I think it's an absolute killer for flat Earth.
Yeah, because if the Earth is flat and there's all the stars move around Polaris, then where the hell does the SCP come from? The South Celestial Pole.
Yeah.
And what's it moving around?
So I think it would be an opportune moment now to say to anybody who's in the chat, especially if you're a flat earther in the chat, I challenge you to answer the two questions. Why are the stars, looking at the stars in the star trails, not oval in shape? That's one. And the second challenge to you is, how is it even possible to have star trails? It's in a circular formation in the south. I mean, this poses another problem for you, and that is, where in the south? Which continent? In fact, there'd be infinite positions around the Earth facing south in which you'd see exactly the same star trails. That's just totally ridiculous.
Yeah, they might be rotated around a bit because you're further around on the Earth, but they'd still be the same stars relative to each other.
They'd be the same stars, and if you were in, say, Cape Town and Sydney, you'd actually see them at the same instant. And you're talking about being around about 150 degrees facing in different directions. So that is just so totally ridiculous. I mean, if you are a flat earther, I'm going to wag my finger at you. If you are a flat earther, then you owe it to yourself, and certainly any of the kids that you're homeschooling, to get an answer to this question. Because if you answer this question honestly, you will no longer be a flat earther. I guarantee it.
I absolutely agree. It's one of my flat Earth killers in my video series. You can't have a South Celestial Pole on a flat Earth. There's no way to work that way.
Absolutely.
Unless somehow all the stars are on a celestial sphere around the flat Earth. But then again, what's on the bottom of the flat Earth? That's every time you answer something about, well, answer with in quotation marks, something about the flat Earth, 1,000 other questions come along. Whereas with the globe, all the questions are answered straight away.
Yeah, exactly. You hear flat earthers saying, "Oh, there's no evidence for a globe." All of the evidence is for a globe. All of it. Every single skerrick of it.
And there's only one type of evidence for flat Earth. That's misunderstood globe evidence.
Yeah, precisely. Yeah.
And
let's carry on. And I've got some other stuff that I spent today. I'd hate to have done it and not show it to you.
Well, to be honest, that's all the bits that I sort out in particular. Unless there's something you'd like to look at.
Yeah, absolutely. So let me just bring this up because I spent a little bit of time with it. So I just want to bring it. Let's have a look at this. I was just thinking about the sun today because it's about 8:45. I think the sun went down today. So let's just share this. I haven't even finished with it.
Daylight saving time.
Yeah, so I'm going to share. So 8:45. So it would be 7:45 normally, right?
Eastern Standard Time.
Yeah.
Emphasis on standard.
Yeah. So let me go to this and I'll just share that screen. Share a screen. So share screen and I think a window, and let's have a look at this one.
Does it have sound? Because you have to select the sound.
No, I don't need the sound. Okay. So here we go.
Oh, hang on. Let me show that. I've got to accept it into the stream. There we go.
Yeah. Okay.
Away you go.
All right. So looking at that. Okay. Oh, I can't see it on YouTube.
No, just to give it a few seconds. There it goes.
Some people are talking to me on that. Talking. Just tell them, look, I'm sort of concentrating on the screen, so I'm not looking at the chat, but so I will look at it later. So save any questions you have, or unless you can look on my behalf too. So anyway, so this says here, not your map. Then choose one. So there's a couple of things. I've tried to cram a few things in here. No problem. So flat earthers are expert navigation. So let's have a look. We've actually got there. I'm showing you the southwest. This is where the sun goes. There's the flat earth. And don't tell me you don't have one, because you're expert navigation. You're expert navigators. So you have one. So if it's not this one, choose one. It doesn't matter which one you choose. That's not going to change the fact that the sun heads southwest. Okay? So that's where the sun's going. Can you please explain how that works on flat Earth? So
and then how does it reappear in the northeast?
Yeah, exactly. So flat earther, please explain how this is going to work, because this works absolutely perfectly on a globe. All right. So let me just.
Well, while you've got that map up, can I just make a point?
Sure. Absolutely.
So on the 21st of December, or the December equinox, at noon over Perth, the sun will be to the north of Perth. It'll be on the Tropic of Capricorn. I think it's Geraldton or somewhere like that. At the exact same time, it'll be midnight in Ushuaia at the bottom end of Argentina, which is on the exact opposite side of the flat Earth.
Yes.
So if the seasons are caused by the sun moving between the Tropic of Capricorn and the Tropic of Cancer, how come it's still summer in Ushuaia when at that point the sun will be the furthest away it is ever from Ushuaia? But it's summer on that day because it's in the southern hemisphere. It should be the depths of winter according to the flat Earth explanation of the seasons. But you can see it very clearly on this, that draw a line from the west coast of Australia over to the bottom of South America, right through the North Pole. So the sun will be as far away as it gets from Ushuaia in Argentina, which means it should be winter if that theory holds, which it doesn't, obviously, because it's summer there.
Exactly. So let's have a look at another one. Okay. Let's have a look at. So I've stopped sharing, haven't I? Yeah. Okay. Let's do another one.
Yeah.
All right, just a minute while I just grab it. Okay, open. Just bear with me a second. It won't take long.
We got 42 watching. All these people are not out enjoying New Year's Eve. Glad you're in here with us.
Yeah, true. Yeah, absolutely. Okay, so just hang on a second. I'll get.
It's only an hour and a half for you to go, and 2.5 for me.
Yeah. 6. Okay.
We don't need daylight saving in Queensland because we've already got plenty of sunshine.
Okay.
Highest rate of melanomas.
Okay, I just want to go through this particular one. So I'm going to share this one with you, and it's kind of just like an idea. So I just sort of slapped this together fairly quickly. So you might, if there's something wrong in it, just show. I would appreciate you telling me. Okay.
Wow. So, no Flurf would ever say that.
Okay. Okay, so let's have a look at this. It's reasonably complicated. It's got a few things going for it. So this is the sun going away. So let me go through this actual thing over here. So basically, you've got Austin. This is in response to something that he said today. So Austin is there. He's having a look at the sun, and you can see that at noon the sun is, let's say, directly above his head. Okay. All right. Now this would be at at the equinox. Okay. So he's looking. The sun is directly above his head. Now at 45
on the
degrees,
equator.
Yeah. So at 45 degrees. Now I've got these particular. Now this doesn't have to be at noon over here in Australia, right? So again, I can fix that
wherever
time.
he is.
Yeah, wherever he is. Yeah. So at some stage, the sun is above his head, right? Okay, and then 15 minutes later. The sun's moved on. So at 15 degrees an hour. So 15 degrees later. Yep. The sun's moved on. Well, if he's around Australia, then if you have a look here, the radius is at our latitude is 37.4 37 degrees and 48 minutes. So it's 37.8. So if we say that's 127.8 times 69, that's 8,818 miles. Okay. All right. So therefore, that's the radius. So therefore, the circumference times that by 2 pi, we get 55,406 miles. That's around. Again, remember that flat Earth. Okay. And therefore, the velocity is 55,000 miles in 24 hours. So 2,308 miles per hour. This is how fast the sun is going. Okay. All right. So the distance in 15 degrees is 2,308 miles. So pretty much Perth would be sort of where his arm bends. Okay. That would be Perth. So if Melbourne is the top of his head, Perth would be where his arm bends. Okay. But anyway, 15 degrees. So if it's 15 degrees, so if in 3 hours, then he gets 6,925 miles in 3 hours. Okay, and that's a 45-degree angle. Then clearly the sun is exactly the same distance on top.
Yeah.
So flat earthers, you now have a distance to the sun, if you believe this. Okay.
And assuming the sun has the same height all the time, I guess, in their model.
Yeah,
which
so
they don't have.
The sun has the same height all the time, which they reckon it does, right? That's in a particular season, right? So therefore, 15 degrees later, at 60 degrees, you're looking at another hour ahead of you, and then you can see that this doesn't match up because the distances are not linear. Okay,
it's as if it's speeding up.
Further apart. Yeah, it's as if. In fact, the only way that this could be linear, is if this was a globe. Okay, in other words, it went right up in the air like a circle, came back down again, and then you could space those things out evenly.
Yeah.
So this is absurd. In other words, the idea that the sun could actually do this is totally absurd. The other thing which I haven't put on this is that what Whitsit said today was when asked the question about what happens to the sun, he said that light attenuation. Okay, so he's saying that that it disappears as the as the sun goes further away, it disappears and goes away. Well, first of all, if you're thinking about this, how many thousand miles are there on the Earth? Because clearly, if it's 6,925 miles and we've only got we've only gone 3 hours. What's it going to like? What would be like at 7:45 p.m.? Where the hell would we be? Halfway to the moon. So
something like that, yeah.
Yeah. Okay. So and the sunlight hasn't attenuated yet, and when it does, the starlight's available. You can see the stars. So, what is it about the stars that makes it possible to see stars in the same direction that the sun went, and you can't see the sun? So I thought I'd do a little bit of mathematics and work out some of that. And I worked out, well, the sun, from the data is 120,000 lux, and I believe the stars were like about just over 1,000 or something like that. Actually, no. What am I talking about? But 0.024. So basically the sun was 50,000 times brighter than a star, right?
Mm-hmm.
No, 50 billion times. What am I saying? 1,000? Losing my mind. 50 billion times brighter than a star. So this is what flat earthers want us to believe. So if they think we've got far out things that and they're so incredulous about them, like speed and distance. This is what we're expected to believe. We're expected to believe that the sun's light attenuates, It's 50 billion times brighter than a star, and yet when the sun has finally gone, we can see the stars. What fool would believe that? Unfortunately, quite a few of them.
Yes, a small percentage of the human population, but enough to wonder that they actually are human and they don't have enough brains to figure this out.
Yeah, exactly. Anyway, I think that's probably
not to mention the whole idea of the sun sort of, it gets dark because the sun moves away from us, but we never see that. We see the sun go below the horizon. And it clearly does. At a constant rate.
Well, you can see from that diagram that I was showing you there, by the time you get to 5, 6 o'clock, right, then the sun is at the horizon, many, many thousands of miles away, at the horizon. Well, clearly that's not right. That's absurd. That just doesn't work. So why aren't flat earthers, who are truth seekers, putting these things together like this and saying, well, I wonder if that actually could work? Could this sun, could our idea work on a flat earth? And anybody, with any kind of intellectual honesty would say, well, no, it can't. There's huge problems with that. And if there's huge problems,
intellectual honesty.
Yeah. Well, yeah. There's huge problems with this one, where that you just can't make it practically anything work. And then you've got on the other side where everything works. And you say, well, why aren't you choosing the one where everything works? What is it? What's inside you that you're so offended by the globe that you need to deliberately make a choice like that?
And I think Randy gave us insight into that. It was about being part of a group. So it's a very human thing in a sense.
Yes.
But he found people like him, I guess, people who thought like him, and they took advantage of him, obviously, and kept him in there for longer than he probably should have. But he was one of the very few who actually had an inquiring mind. And the same with Seek Truth, Speak Truth. Seek Truth, Speak Truth. I still can't say that. STST, that's easier. He was so adamant that the Earth was flat, and then he just saw a couple of things. Conspiracy cats just showed him one or two things, and then he realized, just like you're saying, it can't be like that. Flat Earth doesn't make sense, does it? So, and that's how he changed. But there's so few with a genuine inquiring mind, and science is based on inquiring minds. That's asking. Flat earthers often say, what's wrong with asking questions? It's nothing wrong with asking questions. That's the basis of science. The problem is you don't listen to the answers. Well, you don't understand them. And you think because you don't understand it, it must be wrong. That doesn't work like that.
Yeah, exactly. Well, I suspect they don't really want to go too deep into it. Otherwise, then they lose their justification. Yeah, they lose the group. And my wife said something today, and she's probably a bit unkind. She said they don't have friends, so.
Well, that's why they stick to their little echo chambers, I guess.
They need to stick to that group, but yeah.
And like I said, it's a very human thing to belong to something, even if it's nonsense. There's plenty of religions started that way, that's for sure.
Well, I'm a pastafarian, so should I say that out loud?
Pastafarian?
A pastafarian.
You eat a lot of pasta, flying spaghetti monster, yes. Pastafarian, yes.
Yeah, so
when you mention food, I get excited, you see, so.
Yeah. Well, look, there's lots, like we said at the beginning, there's lots of people who believe stuff, and, rightfully or wrong, that doesn't matter. I think when you get to the stage where you're saying, well, where this becomes an argument, you're asserting this, you're teaching kids, all of those sort of things, and then it leads to other conspiracy theories, then it starts going a little bit off the rails, and you start thinking, well, that's not, that's just taking it a little bit too far,
Yeah, and first in general, I think a friend of mine who's a teacher said, sort of struck home with me, and it sort of describes for us really. She loved teaching because, you know, you get that light bulb moment when the child understood the complex concept you're trying to explain to them. But then she did the remedial classes, and it was soul destroying because that light bulb moment never comes. And that's what it's like. You're trying to explain something to a flurf who doesn't have an inquiring mind. You know, someone like Whitsit, he's never going to get it because he doesn't want to. He thinks he gets power and prestige, at least in his mind, from spewing out all this crap. And it would be, he sees the loss of that greater than the gain he would get. But you just have to look at someone like Ranty and SDSC and what they've gained from moving away from the nonsense into something that's real. And that's the thing. You can't survive anywhere unless you have a good idea of reality. And if you're going to purposely stick to something that isn't real, well, to the extent of flat Earth at least, where nothing works, you're going to just have a terrible life, really. And Ranty's a good example of that, because he said on a video that he tried to commit suicide at one point. So, you know, it's not my words. He said that himself. It's a sad thing, and it drove him to that point. It wasn't necessarily because of flat Earth. There was about a whole lot of things, but flat Earth was in the mix. Sure. And he certainly was. That's why he gave it away before he came back to reality. So, and that's a wonderful story to see that he's come back and he's so much happier now.
Well, I have heard flat earthers actually say that they've lost family, they've lost friends, they've lost jobs. You know, all sorts of stuff like that over this. And the thing about it is that, you know, I mean, if they're squirming now, it's only going to get worse. I mean, you know, the Jeff Bezos and the Richard Bransons are just going to make it a lot worse for them. You know, and you know, at some stage they got to say, well, we love having some fun with this, or we believe something. Certainly not Earth is flat, but maybe there's some other aspect of something that they want to believe. Maybe stuff that they've heard in the Bible. I don't know, but finally, I mean, you just got to live a reality, don't you? You know, you can't just live this fantasy all the time.
I think we all live a fantasy to some extent. That's what Dunning-Kruger's all about, really. But we think we're better than we are, but that's how we try to be better to some extent. But others take it to the extreme, and that's where they have problems, because they're not matching reality.
I started some time ago. I thought I'd do a little bit of a study and find out to see if I can actually identify a demographic for this, but then it quickly fell apart because at some stage I worked out that most of them were over 40. Most of them were male, and most of them were over 40. But now we're finding people in their 20s. You know, you know, they're holding on to unbelievable technology in their hands, including a GPS, and then believing some absolute rubbish. I mean, for instance, one of the photos I've got, I won't share it with you because it's trivial. You know, I've got on my roof, you know, my dish facing around about 57 degrees, you know, in the sky, you know. Well, for it to be 57 degrees up, and I look around me and there aren't any towers around me. So let's say, for instance, there was a tower 3 miles away, you know, or 10 miles away from where I am, and there aren't any like that. The tower would have to be 300 miles high. Think about that. The tower would have to be 300 miles high.
For a dish at 57 degrees. Yeah. Your latitude wouldn't be not 33 degrees by any chance, would it?
Yeah, it is, but that's the latitude. But the dish will be, my latitude's around 37, but the dish is, because obviously the dish is facing the equator.
Yeah. where the geostationary satellites are.
Yeah. So yeah, exactly. So how what kind of tower would you need? Even if it was 40 degrees, even if it was 30 degrees, imagine the size of tower that you'd need. It's so 30 degrees, just roughly, sine 30 is a half, isn't it? So you're 100. Let's say you're 10 miles away. You'd need a something that's 5 miles high. Can please any flat earther show me a tower that's 5 miles high?
Otherwise, your dish is pointing at something that doesn't exist.
Yet
it works.
Exactly. And how is that not ridiculous to even contemplate that? And how does that not destroy this whole idea about satellite TV being, on towers? That's just so stupid,
Tuss reckons he's built bigger towers from Lego.
Yeah. Oh, Betty, I'm missing the chat. I'm just not good at multitasking. Talking and watching this at the same time.
I put on I missed super chats the other day, so I've put on a third screen so I can keep an eye on.
Have you? No, I've only got one screen, so that's okay. All right, so, no worries.
It's cool. All right. So, did you have anything else to show? Or
no, that's it. We're done.
All right.
That's all good. How long have we been going now?
Hour and a half.
Hour and a half. Yeah, I think
41.
Yeah.
And so I think we've had enough of Whitsit, that's for sure.
Yeah, that's right. I think I like to give Whitsit a message. Whitsit, I don't know why you go around your country, proselytizing as you do, and with your girlfriend, and if you were going to do that, look, if you're going to do that and you had some religious reason for that, I get it, but to go around saying to people that that the earth is flat, and when most people are intelligent enough to know that it's not, I mean, I don't know why you would do that, Whitsit. I mean, you're not an unintelligent person. You could actually do some good with that, maybe do a course and become a teacher or something like that, and then be a force for good, instead of this silliness going around telling virtually every time you say I'm a flat earther, I can think of a dozen adjectives that would be very unkind if I said them, that mean the same thing pretty much. So why would you do that? You know, and you've seen some of the things that you and I have discussed tonight, Whitsit. Just go through them, especially the star trails, and just say, look, yeah, I was wrong, or this doesn't make any sense.
Well, that's going to be the hard bit, saying I was wrong.
So. Yeah,
but it shouldn't be hard.
No, it shouldn't be. So the rest of the flat earthers, ask yourself the serious questions, because you pretend that you are truth seekers. Well, the questions are always there. Answer them. Answer them for yourself, not for me. Not for other debunkers around, because we exist practically to have, to have fun with you. We're here. That's why we do this. We have a bit of fun with you, and we share some information, and we learn a bit of physics and stuff along the way. And there's always that, and we have our friendships around, which I value a lot. So we've got all of that, but underpinning all of that is making fun of people who just are so damn lazy, just won't even have a look at the evidence properly. So I hope you take that advice, flat earthers. And hopefully next year, a few more of you, other than Ranty and STS, will come out of this nonsense and enjoy the amazing technology that's happening right now, and there's so much more to go.
And
That's my
in 50 years, everyone's going to know someone who's been to space, personally.
Absolutely.
So unless everyone's in on the conspiracy, which kind of makes it not a conspiracy, that should be the end of flat Earth. But they'll have flat Mars once we move there, I'm sure.
I've got it on my bucket list. That's not too hard to do.
Judy Bassett has given a super chat of €7. Thank you very much, Judy. No message there, though. So if you're meant to leave a message, you can just put it in the chat and I'll read it out.
Thank you very much.
But I very much appreciate that. And I very much appreciate you, Professor Phil, for coming on tonight and sharing New Year's Eve with me. Subjecting ourselves to the bullshit vending machine that is Austin Whitsit. But Judy Bassett says, "Hi, Blue." Okay, hi, Blue. That's the super chat, I guess. And yes, Blue's in the chat as well. Yes. Yeah. So I hope you have how long is it till New Year's Eve now? An hour and 15 minutes for you, 2 hours and 15 minutes for me.
Okay.
So I hope you have a great 2022.
Thank you.
Happy New Year to everyone in the chat. It's very good. Very pleased to see you all here. It's been a big week. It's been a huge week, in fact.
Exactly.
This is the last of those live streams, but I've already got a few lined up for January, so look out for those, including one with Simon and Dan.
If you haven't already subscribed to my channel, please go ahead and do that. That's if you're interested in the stuff that I do.
Yes, I'll make sure I put a link in the description.
Yeah, and you want 6 more, you said.
6 more to well, let me check. Where are we up to?
I'm sure I can create 5.
I've got it. Hang on.
You've got it, have you?
Yeah, let me.
You're lucky.
Thank you, everyone who subscribed. Let me just move this to a new window. Hang on. Why is this not moving? There we go. So I can share it. I've lost Streamlab. There it is. Share screen. God, this is cumbersome. And there you go. 1666.
Wow. There you go.
So I will.
You better stop. Just let him have a bit of fun with his 666 just for a minute.
No, don't unsubscribe just to keep the number there.
But if you get more, you'll get 667 then as well. So
I'll post it on my community page, and everyone share it as much as you can with Flurf. So that'd be great.
That's true. Yeah, absolutely. So I look forward to anybody who hasn't subscribed. Please go ahead to my channel, and that I will be doing more. As I said, I am retiring, so I will have a bit of fun. I'll be doing some more of this, but I want to do some serious stuff, and I actually want to do some live stream teaching, so that people who come on the live stream are actually in a classroom. Okay, so you'll need to. I'll get you to get your list of resources that you need, and you can join the classroom. And if you've got any teenagers who are actually doing this stuff and it's real life, please get them in. We can, I'd love to help them out. Okay.
All right then. Tuss asks, can you ask the prof what the secret ingredient in your fried chicken is?
It's a secret.
Well, that's exactly the point. Yes. And Dora, thank you for posting Professor Phil's channel just before I did. I didn't see because I was too busy looking it up. And you've also posted a super chat of €1.66. So thank you very much for that. No message though.
Yeah.
But Dora, I always love getting stuff from you. It's
I love
awesome
Dora
stuff.
too. Dora, Merry Christmas. Happy New Year.
Happy New Year.
Christmas is all past. So happy New Year, Dora. You're always it's always a pleasure to see your name out there.
She's a great supporter of many channels. So thank you very much,
Absolutely.
Dora. Okay, so that's just about everything, I guess. Happy New Year to everyone. Have a great 2022, and we'll see you in that year, 2022, and hopefully it's not 2022.
Yeah, let's do it again, okay?
Yeah, this is a do-over. All right, everyone have a great news. We'll see you in the new year.
Okay. So there's nothing left to do but cue the corgi.